Now let's take a look at another measure of central tendency, which is the median. The median, unlike the mean, is not dependent on every single data point in your given set of elements. Arithmetic mean, geometric mean and harmonic mean, all the three different types of mean are dependent on every single value of your data set. But median is not calculated, or it is not dependent on every single value. So median is that centralmost value that divides your entire distribution of data into two equal parts. Now how do you calculate a median? Now to calculate the median, the first thing that you have to do is you need to arrange your data in a particular order. When we say a particular order, we are talking about either an ascending order or a descending order. So one of these should be your primary criterion to calculate the median. Now once you arrange the data points in ascending or descending order, identify what is that centralmost value. That centralmost value becomes your median. Now we understand median with the help of a couple of examples. In the first example, you have 5 data points. So when you have 5 data points, the first thing that you need to do is you need to arrange them in ascending or descending order. Once you arrange them in ascending or descending order, identify that centralmost value. When you have 5 data points, remember that the centralmost value will be your third data point. In other words, this third data point divides your distribution into two equal parts, left and right. So this is your median, value of the median. Now it's always easy to say that when you have an odd number of elements, that the centralmost value is your median. What if you have an even number of elements? That's your example 2. Example 2 has an even number of elements. Now when you have an even number of elements, remember the fundamental step to calculate the median still remains the same. You still need to arrange the data in ascending or descending order. That does not change. So once you arrange the data in ascending or descending order, what you have to do is you have to identify the centralmost 2 values. So let's say you have 4 data points. The centralmost data points after arranging the data in ascending or descending order would be these 2 data points. Now when you observe these 2 data points, simply find the arithmetic mean of these 2. That arithmetic mean becomes now your median. So this is how you arrive at calculating the value of the median. Now the third important measure of central tendency is the mode. Mode is that value which is the most frequently occurring element in your set of data points. Simply put, given a set of data points, identify one particular element that is repeating the maximum number of times. Now there are 3 different scenarios that you have to keep in mind, scenario 1, 2 and 3. In scenario 1, in your set of data points, you will observe that out of all the given values, the value 4 is occurring the most number of times, and hence the mode is 4. It's as simple as that. In your second scenario, you notice that none of the values is repeating at all. So what do you do when none of the values is repeating in your data set? It simply means that mode is ill-defined. In your third scenario, you see that the values 3 and 4 occur maximum number of times, which means there are 2 values that are most often repeating. Then in such a case, modes are 3 and 4. So remember this, arithmetic mean is always unique, geometric mean is unique, harmonic mean is unique, or in other words, mean is always one unique value. Median is always one unique value. Mode need not exist, it need not be a unique value, while mean and median exist and they are always unique. Now let's understand the behavior of mean, median and mode when the values in your data set change. When we say values in your data set change, what would be the impact on mean, arithmetic mean, median and mode when, let's say, every data point in your data set is increased by a constant value or decreased by a constant value, either additively or multiplicatively? Let's understand that. So to understand that, let's say in your data you've calculated arithmetic mean, median and mode. Let's say you represent arithmetic mean by A, median by M and mode by E. Let's say these are the values of your mean, median and mode. Now your data is, let's say, x1 to xn. You have n data points. Let's say you increase the value of every data point by a constant number k. So every xi becomes xi plus k. So x1 becomes x1 plus k, x2 becomes x2 plus k, likewise xn becomes xn plus k. Then your arithmetic mean will also increase by that constant value. Your arithmetic mean now becomes a plus k. Similarly, if you decrease every data point by a constant value, then arithmetic mean also decreases by that constant value. A becomes a minus k. The same is true for median and mode also. So this tells us that when you have a set of n data points, you increase or decrease, you increase or decrease every data point by k. So plus or minus k to every data point will impact arithmetic mean, median and mode. Similarly, arithmetic mean becomes a plus or minus k, median becomes m plus or minus k, likewise mode becomes e plus or minus k. Now this is when you add or subtract. Now let's see what happens when you multiply or divide every single data point with a constant value. So when you have n data points x1 to xn, let's say you multiply every data point by constant value k. So x1 becomes kx1, x2 becomes kx2, likewise xn becomes kxn. Then arithmetic mean again gets multiplied by that value k. Arithmetic mean becomes k times of what it was previously a, so it now becomes k into a. Median becomes k times m and mode becomes k times e. Here's a small exercise for you. You might want to test this by taking a set of random values and increase and decrease every data point with a certain value and multiply and divide every data point by a certain value and check for yourself why these results are valid. Now, what we also need to know is the behavior of median. When you talk about median, remember, we already discussed a little while earlier that median is that central tendency that does not depend on every single element at all. So we are talking about that centralmost value that divides the distribution into two equal parts. That tells us that once you have arranged your data points in ascending or descending order, increasing the largest value will not impact the median, because your ascending order still remains in ascending order. There is no change in the order of the elements at all, which means median does not get impacted. Likewise, point number 2 says decreasing the lowest value will not impact the median. So when you decrease the lowest value still remains the lowest value, and hence there is no impact on the value of the median. So this is an interesting aspect of the median.